Hello, everyone. My name is Ayyoub Momen. I'm founder and CEO at Ultrasonic Technology Solutions and going to talk about the direct contact ultrasonic drawing that we are working on. So to set the stage, I would like to mention that drawing can be done for free, as you can see in this picture. But the challenge is the strict industrial drawing requirements. Whether we are talking about drawing the speed, extent of the drawing, product quality. In some processes, you need disinfection. There are some strict disinfection requirements, wrinkles in some cases. And for example, for building material, drywall, gypsum wall, gypsum board, the heat is required to promote, high temperature heat is required to promote certain chemical reactions. So the process requirement is where the discussion should start, I believe. So we have done some studies, and as you know, I mean, drawing can be done either thermally, as you can see in the picture on the left, or it can be done mechanically, as shown in the picture on the right. The y-axis here is electric efficiency, and x-axis is drawing time. On the left figure, which is thermal method, we consider electric resistive heating drawing, heat pump drawing, natural gas air drawing. On the right, we consider these mechanical drawings include press drawing, centrifugal based drawing, vibrational drawing, that what we are focusing on, and compare it to the state of art. It's no surprise that when you compare the picture on the right to the left, mechanical drawing is almost always order of magnitude more efficient than conventional thermal drawing methods, mainly because you don't need to overcome the latent heat of evaporation of water. But something surprising here is that even in the worst case scenario, when you have electric resistance heating element, if you remove some constraint on the drawing performance or drawing requirement, you can get the efficiencies above 1 for even electric resistive heating element. What I mean here is shown in that gray box here. If you let something dry in a matter of 2 hours, for example, if you don't need fast drawing, you can probably mix dry ambient air to your resistive heating element, and combination can put you barely above that efficiency 1 level. So all I'm saying here is that requirement is important. I mean, when we are talking about what we are talking, I mean, what process we need to just know actually what are the process requirement. The disappointing thing here is that these are electric efficiencies. If we want to convert those to the primary energy efficiency, probably we need to divide all these numbers by a factor of 3, which is associated with the conversion efficiency from natural gas to electricity. So if we are concerning about environmental impact and CO2 emission, to me, the primary energy efficiency should be a figure of merit. This picture is a very simple thermodynamic limits of different technologies, including electric resistive heating element, natural gas, heat pump, electric driven heat pump technology at 50% of the Carnot efficiency and 80% of the Carnot efficiency. Also, I highlighted the industrial processes, generic delta T that you need for industrial processes. As you can see, up to probably 60 degrees C temperature difference, usually heat pump is the existing technologies or heat pump technologies is more environmental friendly, but above 60 degrees C and beyond, natural gas and steam drawing is more efficient. So here just clearly shows there is R&D opportunity to significantly increase the heat pump or Carnot efficiency associated with heat pump technologies. So let's go back to what we are doing. We invented the direct contact ultrasonic drawing, similar to what you see in the nature when animals jump into the river, they come out, they shake their body, and by doing that, they repel a lot of moisture from their body mechanically. We are doing the same at much higher intensity and shaking wet material by piezoelectric transducers. Through that process, a lot of moisture is being mechanically extracted from wet material, and coming out in the form of cold mist, as you can see in this picture on the bottom right. And that moisture can be collected or reclaimed or vented out. The pros is that our technology is 5 to 10 times more efficient than the conventional thermal drying processes. It is 2 to 10 times faster than the conventional processes. And unlike the thermal drying, it works even better for the thicker material. For example, if you're talking about drywall, the thermal drying takes a lot of time to penetrate. It takes a lot of time for the heat to penetrate into the material to evaporate water. But with our direct contact ultrasonic drying, we demonstrated that our technology is even more efficient and even more faster on the thicker material. The cons is that unlike the generic thermal drying, customization needed. One design doesn't fit all the processes. So our primary market is textile and hospitality industry. Example of the process is shown here. A typical process speed of the fabric that's going into these machines are about 1 meter per second. They are already drying these fabric material, textile material down to 85% remaining moisture content through the mechanical pressing. And from that point on, every 5% additional drawing save anywhere between $30,000 to $40,000 energy every single year. So our machine, as you can see in the bottom right, our machine, or we call it ultrasonic modules, can dry these textile material from 85% down to 60% very efficiently, very fast, with ROI less than 20 months. Our long-term goal is to tackle paper and pulp industry. Hopefully, if we get resources next year or so, we would like to do more research on this market segment. Definitely, it's the largest market segment out there, but it is probably the most challenging one with very strict requirement. It's the third largest consumer of industrial energy. The new TAD or true air drying technology, which was initially introduced in 1960s and the patent expired in 1990s. It costs somewhere about $250 to $800 million, just one single machine. Based on our customer discovery, we realized that we cannot sell a totally new dryer machine in the US market. We may be able to do it for China or some other countries who are installing a lot of new plants. So for that reason, only retrofittable solution means like pre-dryers are acceptable mainly in the US market. The process speed is very strict. They are moving these sheets of paper or tissue at the speed of 6,000 feet per minute. It's as fast as how you are driving the highway, 75 miles per hour. And the residence time of the sheet of tissue going from one side of the dryer to the other side is less than half a second. For that reason, they require a lot of or high temperature above 430, 440 Fahrenheit to be able to do it at such a fast pace. The market acceptance is about 10 to 15 years, and US market demands for premium product that are made through air drying machine, which is usually less efficient process than LDC. So our project and machine performance, if we apply our pre-drying ultrasonic technology, it should be able to dry paper from 22% consistency to 50% consistency and bring a lot of energy saving with payback period of 19 months or less, and ongoing energy saving of $2 million for a sample plant or sample machine. On the picture on the bottom right, you see some of the performance results of our ultrasonic drying. Thank you.